Hi, my name is Julia Silge, and I'm a data scientist and software engineer at our studio. In this video, I'm going to show how to use this week's Tidy Tuesday dataset on MMR vaccination rates in schools to show how to train models to examine how to look for differences in groups, how to do more statsy inferential kind of analysis. This is a great video if you're wanting to know how to get started using tidy models, and if you want to know how to get out probabilities from classification models, and how to answer questions like how can I tell using the data that I have if there are differences, and if differences are something I can be certain about, and how to share those kinds of information with others in plots.
All right, let's get started. So today in this video, we are going to use Tidy Tuesday data about MMR vaccination rates. And this is going to be a great video if you are just getting started with tidy models. It's going to be less machine learning oriented and more statsy inference oriented. Let's get this pasted in and started. So this data is about, it's school level data about vaccination rates, and for every school it has like the name of the school, what state it's in, information about how big the school is. It has an MMR vaccination rate, like what proportion of the students, I believe the kindergarten students, are vaccinated, and then an overall vaccination rate. And it looks like when the there's no data, it's coded as -1. And what we're going to do is we're going to train a classification model showing for the MMR vaccination rates, so whether it is above or below the recommended threshold. The recommended threshold, it turns out, is 95%. Like, are the kindergarten students, are 95% of the kindergarten students, do they have the MMR vaccine? So let's and we are going to do this looking at comparing states by states, and we're going to build a model that can say, are there differences state by state, and which states are different from each other, and can we quantify how different they are? So let's build a data frame that will do that for us. So we are going to start here from our measles data, and we are going to let's filter the ones that we have some MMR data on. It doesn't have -1 there. And then we're just going to transmute and just keep, we're only going to keep state, that state level data, a state, and then we're going to create a variable called MMR threshold, and we're going to use dplyr's case when, and say when MMR is greater than 95, we're going to call that above, and when it is all the rest of the time, we're going to say that it is below. And then since we're going to be doing modeling, let's say mutate if is character factor, so that we have our anything in this case, which is just one thing, but anything that is a character, let's change to a factor so that we can do some modeling with it. All right, so now we have measles DF, which is 44,000 rows. What do we have here? Okay, we've got 20-ish states, and we have MMR data for them. All right, so let's just get a real quick. We can just do skim measles DF real fast to see what this is like. There's not a ton in here, but we can see that, it's California, Illinois, New York are the highest. Looks like about over 2/3 of the data is above, 1/3 is below. Since we are doing slightly more inferential work here, let's make a plot showing us what in the data, what do we see is the relationship between the state and this threshold that we have here. So what is the mean or what is what percentage of schools in each of the states are above this threshold? Let's arrange this so we can see it. What is at the top? Whoops, no, MMR like that. So Illinois, New York, Pennsylvania are at the top. They have the highest rates. Let's see what's at the bottom. Arkansas is really low, extremely low. Washington State, North Dakota is that right, or are we missing data or something weird? Let's look at Arkansas real fast. Let's pull MMR. Okay, yeah, there's just a ton of examples in like the 70s and 80s. Like a lot of the schools are below the threshold. So it looks like that's real. Let's make a quick visualization so we can see this. So let's put state on the x-axis, this percentage on the y-axis. Let's make it colorful because that is always nice. And let's make a bar chart. We don't need to see the legend in this case, and that's a proportion. So let's it's always nice, I think, to put the make it look like, whoops, scale label. Did I do it wrong? What did I do wrong here? So if we do this, not color fill, scale Y, continuous, labeled, not a double plus, there we go. Okay, let's look at that. Okay, it's a good start. Let's put these in, they're in alphabetical order right now. Let's put them in, let's use fact reorder to put them in order of their what proportion of the schools have that are above the threshold, and let's flip it so that we can read some of those levels there. Okay, so Illinois has the highest. Illinois, New York, Pennsylvania. Arkansas is incredibly low. Washington, North Dakota, Maine, and so forth. I live in Utah, and we're kind of in the, that's shockingly low, half, but that's in the middle of the distribution. Okay, so that is what we are going to use modeling to understand how certain are we about those, about these values, and how certain are we about differences between states. So we're going to use the tidymodels framework to build a model that's going to help us understand this. So we are going to, this is a classification model. We're going to say model which schools are above and which schools are below that threshold. So we're using the logistic regression function. It's a function from Parsnip. It has mode equals classification. We're going to set the engine for this model using GLM. So just a straight up classic a general linearized model version of logistic regression, and then we are going to fit it. We're going to fit MMR threshold explained by state. So this is a very straightforward model, and we are the model where the data that we're training on is this measles DF. So let's call this GLM fit like so, and it's going to fit it. And these are the results that we get. So we get this is the the print method that tells us what it's doing, and we can tidy the fit method here to show us these results here, and we can see like which p-values are p-value is less than 0.05. We would like to look at that threshold and see like which states are different from the base level would be Arizona. Which states are different, because it's the first in alphabetical order, which states are different from Arizona at the P value, at that threshold, at that which does the model think are different? And so Washington, so Arkansas, you know, it has a big value here, like it's really big. Washington, so it is likely to be different than Arizona. Washington is also down here, and everything else we see is on the other side, meaning that it is has these higher values of being above the threshold, being above the threshold. So that we see these values, and so that's good. So you know, logistic regression models, what even are these numbers? It's on the logistic scale, and right, what even is this? So one of the great things about the tidymodels framework is how consistent and predictable it is to get out different kinds of predictions. And we can use this to talk about this in a way that is much more transparent, especially when it comes to talking to stakeholders. So let's say you're like, wow, look at these great estimates. What am I gonna tell people about these numbers? So what we're gonna do is let's make some predictions on some new data. So for example, let's use the crossing function from tidyr, and let's make for every state that we have, so unique in measles DF state, and then for so oh no, wait, we don't need a crossing. We're just gonna say Tibble. So we are gonna say for this is our new schools. So our new schools are this Tibble of all the schools that we have. And we are going to, because that's the predictor that we had with state. So we are going to now make some predictions. So we're going to predict two things. We're going to predict the mean and the confidence intervals, because that's the reason we train these models, right? Is like what help me understand, like what's the variability given the data we have. How certain are we about the proportions that are above and below the threshold in these schools? Okay, so first let's do our mean prediction. And we use the predict function on this fit that we have. The new data is these new schools, and we're going to say type equals probability, like this. So this gives us for every state the prediction that it is above and below. We're just interested in above. So for Arizona, the mean prediction that a school in Arizona above is this. The mean prediction in Arkansas is this. The mean prediction in California, remember, which is one of the highest ones, is this. We also can get the confidence intervals. So we'll do prediction, GLM, fit. Same thing, new data equals new schools. Oh, I should have copied and pasted. And type equals confidence interval, like this. So now we'll get the confidence intervals, like so. So look, predicted of lower above and predicted upper above. So this is the confidence intervals for that for this class that we have right here. And this, boy, if you've ever tried to get a confidence interval out of a logistic regression model, this is so much better. This is so much better than the other ways that that have existed before the development of this tidymodels ecosystem. So, and we can just bind this all together. Bind calls mean prediction, bind calls confidence interval, like so. And let's call this schools result, like so. Like here we go, schools result. So now we have for Arizona, mean prediction here, and then the low and the high confidence interval there. And we can now make a nice little visualization that is going to show us this. So this is for, let's go up. It's going to look really similar to this. Here we go. Let's paste here. So state. So instead of MMR, we're going to use this predict. And let's make that. Oh yeah, not MMR. Predict above like that. So this is good. And now what we're going to do is we are going to add let's add it on top of the columns. Let's add error bars. And we're going to just put them on top of that column. And so let's say the Y min is equal to the predict lower above, and Y max is predict lower. Oh, I did predict upper. I'm sorry, upper above. Like so, and I'm probably gonna have to give this a different color. Yeah, it's black. Let's make this color equals like gray, I don't know, 70, and I don't know. This is pretty good, I guess. Like so. So let's zoom on this and see. Oh, that's too light. All right. Let's, where'd you go, plot? There you are. Okay. So, so what we have here now is the proportion and then the uncertainty on the proportion. A measure of the variability on the proportion. And so we can see California, we measure much more precisely than South Dakota. Is the model able to tell the difference between California and South Dakota? You know, we're able to get that from this visualization. Like that's what we're able to see here. Let's so that's what we get. That's what we get out of this tidymodels framework. And being in any type of model that you use, you are able to use the same kind of ability to get out the probabilities or the confidence intervals. In fact, let's try to do that. This is a little fancy, I guess, but let's try to let's say, oh, GLM isn't good enough. Let's train a Bayesian model. So let's see if I can do this. Let's see if is it detect? Yeah, that's what it is, I think. Detect cores. Okay, so what we're going to do is we're going to take this model and we're going to paste it down here. And instead of GLM fit, let's train a Bayesian model. Let's call it Stan fit. And we set the option of Stan. Everything else stays the same. Well, I guess we should set priors. We should set priors. So I think there's two things. There's prior and prior intercept. And let's make a prior dist. And we can do like a normal here. We should talk about, so a Bayesian expert to say what we should put here as our prior. I do not claim to be a Bayesian expert, so I'm gonna put the student function here, which is from the rStanArm package. See, it says you need to specify your priors explicitly. Don't, even if you're using the defaults. So let's use student T, and I think how wide should it be? Like DF1 would be the widest. Let's try 2. Seems good. Okay, so then we put this in here. Prior equals prior dist prior intercept equals prior disk, like this. Okay, so this may take a moment to fit. Let's see how fast this goes. So it's setting up, so it's using my cores, and it is going to set up, and setting up this Bayesian modeling. So it's fitting the same model, and notice that I specified it very similarly. I just had to change the engine, and then I had to tell it some things that are specific to that engine, which are the priors. And now it is going to go through and do its computationally intensive thing here. I am going to pause recording and let it go through, because it actually does take a little bit for this to fit, because there's all these different states in here that it's going to try to fit. So I'm going to pause here and then come back once this model is done fitting. All right, we're back. So this model finished training. You can see here we got to the end, to 100%, and it finished its training here. So we can see what it looks like here. So here's the median, and it tells me what it did. You know, it's a binomial, and the kind of model that it did. So what we can do now, because we use the tidymodels framework, we can use just almost this exact same thing that we did here. Instead of stanfit, or instead of glmfit, we put in stanfit. And let's change the name of these things to Bayes prediction and Bayes intervals, because I hear they're not confidence intervals anymore, they're credible intervals. And let's call this the Bayes result, like this. So now we've got our Bayes result, which is in the same format as our other results. So this is where tidymodels really gets you far, is when you want to compare different kind of models. You want to have really predictable results that you are going to know what you're going to get back. And so let's make a little visualization here at the end, comparing these results. So we've got our first result that was, let's say model equals GLM. And then let's bind it to the Bayes result. Bayes result. And let's say mutate model equals stan. Like that. And then let's go back to this visualization, and let's paste it here. This should all work. Instead of a column, let's go to a point. Let's go to a point, and let's we're gonna make the color. We are gonna make the color the model instead of the state. And we are going to, anything else? So let's take this off so that the error bars are the same color as well. And these are probably going to need to be big to look nice. And let's make this a little wider and a little see-through, because that's usually nice. And let's see what this looks like here. Oh, that color equals model, like this. Okay, we did it. Okay, so can we do this so that we can see any difference? It's difficult to see. Okay, well, so I can use Dodge to put these next to each other, but in the interest of time, I'm just going to leave this as is. So we have the states along the y-axis here, and so now this this probability that we got out, it is the same. We can interpret it the same way. It's the proportion. We've modeled the proportion of schools that are above the threshold, and this is much easier for me to like talk about with shareholders, right? And I could fluently get it out of my model when I use the tidymodels framework like this. notice, I hope you can see how that, using the stand model didn't get us a ton here, probably partly because of the priors I used or whatever, but like I'm able to check it and see, and if I have information that I would like to incorporate into my priors, I can do that and then compare quite using ggplot2 to be able to see what the differences are. So that is what we did today. We were able to explore and see what these differences are state by state in this MMR vaccination rates in schools.
Well, we did it. We use this data on vaccination rates in schools to be able to explore and learn that, say, states like California have high numbers of schools that are above the threshold. Schools like Arkansas have low proportions of schools that are above the threshold. And we use the tidymodels framework to be able to try different kinds of models to be able to get consistent, predictable results out. So I hope this is helpful, and see you next time.